So, hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 256, and in this video we want to talk about the keyword virtual again, and especially about the virtual function specifier. Very important about this keyword virtual is that you are not mixing it up with the other keyword which we already learned, also virtual, but in other use, which was using in the inheritance place. For example, here, let me show you this one in code again. So you can see I copied this example here, what we have here, just to the here. And you have to keep in mind, here is, for example, the new thing what we are going to learn, the new virtual keyword with a function, right? This is the new thing what we are going to learn, and this will be also called that's why it's also called virtual function specifier, because it is in combination with function. And we learned the other keyword was virtual with the inheritance specifier, which means here, and you can see in this case, for example, there is no virtual keyword, but we know there is an invisible public, and we know if we want we can make this virtual, of course, if I can write it right. Virtual, and the meaning here we learned already means it is just creating a shared base when we derive it again with another from the same base with the same virtual. So that's the first thing sorry that you should not mix. Virtual here is just with inheritance, and what we are learning is with a function specifier. And with that, we learn else what I explained to you in my last video a little bit, what this relationship is means, or let's say how it is used. For this purpose, we dive now into this example, and we will start reading this little explanation. Careful, this explanation is an overview. It's not describing in detail, but we start with this overview. And then when we dive here, go down here, it starts explaining all that stuff here again in detail. And what I want to do is, in this video, I just go fast over this one here. And in the next video, I will go into details. But before I go into details in the next video, of course, you can try to learn this by your own. Try to understand this in details here, what they are trying to explain on your own. And the reason for that is you can train to read this CPP reference site on your own, and that is more or less also our goal as a beginner, to understand, to come closer to the official documentation, right? And we know the CPP reference is they copied out parts of the official documentation and try to summarize it here up. All right, so let's get started with that. So let's go here. I will read this and then try make some notes, because like I said, this is not a real full explanation. And let's get started. So the virtual specifier specifies that a non-static member function is virtual and supports dynamic dispatch. First of all, it works only with non-static member function, which means just every, let's say, most functions which has not the word static, right? If you find here a static function, it will not work. All right, and here it's important, it is indicating this with the keyword virtual, like I said. You already know a virtual function when it starts with virtual, that will be a virtual function, but careful, that's not true, because with virtual functions there is a start point and an end point. The start point is indicated most time with virtual, right here, but that means not that that till the end point all are also made visible with virtual. For example, you can see here this function has here not the keyword virtual, but actually this function is also virtual, and we will see what it means this later again here in detail. You can try to understand this and it will explain it there, but important is that you understand there is a start point the start point will have this keyword virtual, because indicating, okay, this function will be treated as virtual. And then we will learn what it means go to the endpoint, all the virtual functions. Okay, let's go here a little bit more. And then it says here dynamic dispatch. And this dynamic dispatch is actually what I mean. It starts from here and it will be still virtual in derived class. You can see this class is a base. For example, it starts as a virtual function. Later I derive from this base. And this dynamic dispatch means just it will be here also considered to be virtual when we understand this more in detail. All right, let's go on. It may only appear in the declaration specifier sequence of the initial declaration of a non-static member function. For example, when it's declared in the class definition. So for example, again, here an example here. It may, and this is that what I said, it may only appear in the declaration specifier sequence. This is the start point. Right here they are saying that also it may only appear here because it appears only here, but the second one, the derived one here, is also considered to be virtual, and we will learn this a little bit later here in the details more. But that's very important that you know that this one is also considered virtual, because there is a effect which we have to understand. All right, let's go to the explanation here. Let's say here it says virtual functions are member functions whose behavior can be overridden in derived classes. So first of all, it's a member function. Member function, we know what it means. It is within a struct or a class. That's why it's a member, and it's a function. Yes, we can see we have here function void f. And when we say, when we add this virtual keyword, then it's a virtual function, and it's a virtual member function. So important on this sentence here is that you know what it means, this one. And this is the thing what some people make wrong, perhaps not wrong, but explain it wrong. At least on the internet I see some wrong things, because it says here can be overridden. And on the internet I see many think they have to be overridden. So when you say this is virtual here in the base, you have to override it in your derived class. This is some argumentation on the internet. Careful, that's not true. It says here can. Can means optional to be override. You still can keep this virtual on the base and don't do anything here in the derived class. So that's very important, side note. And the next very important thing here is can be overridden. Let's see. Here's this optional keyword. It's not a keyword, sorry, it's a specifier word or something like that. This override indicator. But it's not a keyword, we see it's not blue, but this is also almost soon very important. The point is now this override, it says here, is optional, right? Optional means this one, you can omit it, and when you omit it, the compiler still treats this one as override when you have overridden it, right? Here, so in the base here, let's go here, start here again, my start point, it has a virtual. Now I know this void f here is a virtual function, and here we have the same function in the derived class. You can see it is also called void f, so you can see, and here it says override, but yeah, and this is optional, but important is here again the body. You can see it says here stdc out base, and here I override it with stdc out derived. So this means just override. This one indicates it is override. Important is optional. So you can omit this one here, and the compiler treat this still as override. Important, it treats this as also virtual, because this keyword virtual will only indicate at start, but even at start you can even write here virtual as well. But we will see this later more in detail, like I said here. All right, I hope that makes a little bit sense. If not, no worry, we will go in detail. But here is one more catch with this override. It says here override is optional, right? If you use the override, then you have to provide a virtual function which is to be overwritten. That's very important. But on the other side, if you have already a virtual function here, you can omit it, which means you don't have to. That is sometimes also a little bit confusing, but we will train this and we will test this also. I make an example and perhaps we see this anyway later. All right, let's go on here with this text. Also, as opposed to non-virtual function, the overridden behavior is preserved even if there is no compile time information about the actual type of the class. And this one is better that I make an example, which means more or less, later in example we will see it, that this override here behavior we still have it, but like I said, this explaining is not so good. Later in the examples, when we come there, I will show you that more in detail. Then let's go. It says here, that is to say, so you can see they explain it here, I think. Also, if a derived class is handled using pointer or reference to the base class, a call to an overridden virtual function would invoke the behavior defined in the derived class. And that is the new thing what we have to understand. That's interesting. That is a virtual function call later. This is the new thing what we have to understand. What I mean with that is you are calling, for example, this function here, and it will then, like I said, there is a start point. There will be an end point. In this case, we have only the base and the derived. So it then here's again the function. This is my endpoint. And then it will go and find the endpoint and will use this as the last call. So even if I call this one here, it goes down to the endpoint, or it's called the final point or the final destination or whatever. And it will use that. And how does this work? Again, in the examples we will see that. But this is the thing what we are going to learn. And let's see, such a function call is known as a virtual function call or virtual call. Like I said, this is the thing what we have to learn, exactly that it has a start call, and then because this one is not the final destination, it will go down and go down till it finds it and then it uses it. And how does this use it? Again, here you probably don't understand it, no worry, in the details here, when we go there we will understand it. But again, you should try this as an exercise for your own to try to understand this CPP reference com for learning purposes. So, and let's go here a little bit more. It says then, virtual function call is suppressed if the function is selected using qualified name lookup. What a qualified name lookup is, it is explained here. Let's read a little bit more. That is, if the function name appears to the right of the scope resolution operator. Okay, and here is an example. Also, when we scroll down here is, for example, our BR is an object was created here. You can see it's a reference object, and then we use the dot, and then we call the base. We notice we can call the base, so specify what function I want. And here, important is, here we use the scope resolution operator, and here the function is on the right side. That means here, let's go this again. That is, if the function name appears to the right of the scope resolution operator. You can see the function here is on the right side of this scope resolution operator, and then it will be suppressed. The virtual function call, what we will learn new, is not used. And in short, let's say I call this one here. When I make a virtual function call here for void f, this is the start point, then the compiler check if this is the final destination point, and it says, oh wait a minute, I found another virtual function here, and then says this one is my final destination, and it will print out this one. This is what we will learn. But this last sentence says what we just read. If we use the scope resolution operator, it says, okay, I find again the virtual function here, but this time I will suppress it, which means I will not use the behavior. I will not search the final destination, which means I will not check derived classes if they are virtual. I will just take it. So you can see it prints out two-time base here. So here it says I print base. So that was the overview explanation what we are going in the next video in detail. So you can see it says here in details how this works all step by step. Again, if you don't understand anything right now, no worry, because that was high level view and not very informative. That was just that yeah, little introduction, I would say. But again, try to understand this as an exercise here for your own, because you as a beginner is still our goal is to understand this documentation for future purposes, to understand the official C++ documentation, so we don't have to ask anyone how something works in C++. We can just look up ourselves how it works, and that's our last goal, I would say. So we are independent of anyone and can research ourselves all. Alright, with that said, if you have any questions or any comments like all time, write in the comment section, and see you in the next video. Have fun, never give up, and bye.